Okay, so I started to make this video and then somebody knocked on the door, so I'm starting over again. So number 8 from the packet, there's not enough room to do it on here, so I copied it onto another piece of paper. And the first thing I want to do, I'm trying to get the x by itself, so you can think of this as like the problem 2x minus square root of 2 equals 0. What would we do first? We would add square root of 2 to both sides. So that's what I did first, add square root of 2 to both sides. And then I have this. Okay, I now have 2 times cosine blah, blah, blah. So to get rid of times by 2, I'm going to divide both sides by 2. So I get cosine 2x minus pi is equal to square root of 2 over 2. Hey, that's starting to look familiar. That looks like something on our unit circle. So if we look at our unit circle, one of the versions of our unit circle actually has, where is it? Here we go. So we have a couple different versions of the unit circle. So notice this version of the unit circle has that square root of 2 over 2 on it. That's the same thing as 1 over the square root of 2. Okay, so we're used to seeing this as 1 over the square root of 2, but it's the same thing. So what I'm going to do is I'm going to say, okay, cosine of theta equals square root of 2 over 2. So I'm going to let theta equal 2x minus pi. And that way I can just figure out what is this whole thing, what angle does it have to be equal to? So what angle does that have to be? So looking at my unit circle, square root of 2 over 2, cosine is the x. It's right here, and it's right here. So pi over, oops, you can't see that. So it's at pi over 4 and 7 pi over 4. It gives me a cosine of square root of 2 over 2. Okay, so I'm going to write those down. So theta could be equal to pi over 4, or it could be equal to 7 pi over 4. But notice my domain. My domain says x needs to be between pi and negative pi, but x is being times by 2, so that means that I can change my domain. I can make my domain twice as big. If we're going to find all the x values that when I multiply them by 2 and subtract pi from them is still falls, whatever numbers for x, we can actually double the domain. We can double the domain, okay? Because when I'm solving these, when I'm solving my theta, for theta, it's going to get divided by 2. So these angles here are going to get divided by 2. So that means I want to start with them twice as big. So when you have a situation like this, what you want to do, if x is being times by 2, you want to multiply your domain by 2 also. If it had been multiplied by 3, you would multiply your domain by 3. Okay, whatever your x is being multiplied by, you want to multiply by your domain by that. Likewise, if it was being multiplied by 1/2, you would want to multiply your domain by 1/2. Okay, so here's my new domain. So not only am I going around to pi, but I want to go all the way to 2 pi. So this takes me to 2 pi. But notice it also has negative. So I want to go the other direction as well and write down all those answers. So if I go negative, that would be this way. This would be 1/4, negative 1/4, negative 2/4, negative 3/4, negative 4/4, negative 5/4, negative 6/4, negative 7/4. So I'm also going to have negative pi over 4 and negative 7 pi over 4. Okay, because my domain goes in both directions. All right, so now I'm going to set each of these equal to 2x minus pi. That's why I was saying I needed more room on that piece of paper. Okay, so now I'm going to substitute back in for theta 2x minus pi. So 2x minus pi is equal to pi over 4. 2x minus pi is equal to 7 pi over 4. 2x minus pi is equal to negative pi over 4. Whoops, I'm running out of room again. And the last one, 2x minus pi is equal to negative 7 pi over 4. All right, so let's solve this. I'm going to add pi to both sides. So I get 2x is equal to, pi is the same as 4/4. Okay, pi is the same as 4/4. So I have 4/4 plus 1/4 gives me 5/4. Now I'm going to divide both sides by 2. So when I divide by 2, the 2 ends up just on the bottom of the fraction here. So I get x is equal to 5 pi over 8. So there's the first answer. Now I'm going to check this against my original domain. Oops, can't see that. I'm going to check this against my original domain. Let me zoom out a little bit. My original domain said that x had to be between negative pi and pi, and this answer is less than pi. 5/8 is less than 8/8, so this one's okay. So I'm going to keep that one. There's one answer. Next one, same thing. Add pi, I get 2x is equal to, remember pi is 4/4. 4/4 plus 7/4 would be 11/4. And then I'm going to divide again by 2, so just like I did over here. So I get x is equal to 11 pi. The 2 is going to go on the bottom, so 4 times 2 is 8. Okay, now this one does not work with my domain. This one, 11/8 is bigger than 1, so that doesn't work because x has to be less than 1. So I'm going to throw this problem out, that answer out, sorry. All right, next one, add pi. 2x is equal to, this is 4/4 minus 1/4 is 3/4 pi. And then divide by 2, x is equal to 3 pi. 2 times 4 is 8. That is less than pi, so I get to keep that one. Okay, and then the next one, I'm going to add pi, and I get 2x is equal to negative 7 plus 4 would be negative 3. Negative 3 pi over 4, and then divide by 2, I get x is equal to negative 3 pi over 8. Okay, so one thing I'm wondering is, could there be another answer going around in the negative direction? Because I had to throw out this one, because when I added pi, it made my answer too big. So what I'm thinking, though, is there might be another answer, and actually when I published the answers for this problem, I hadn't thought about that. So I think I'm going to go around a little bit farther on my negatives. So back to this step right here. I'm going to keep going. After negative 7 pi over 4, let's keep going. What would be the next solution? So here's negative 7 pi over 4. This would be negative 8 pi over 4. Negative 9 pi over 4 would be another angle that would have a cosine of square root of 2 over 2. Because that's going all the way around the circle and then a little bit more. So I'm going to try one more of these. 2x minus pi is equal to negative 9 pi over 4. And see what that does. See if I can use that one. So I'm going to add pi, and I get 2x is equal to negative 9 plus 4 would be negative 5 pi over 4. And then divide both sides by 2. Aha! There was another answer. 2 times 4 is 8. So there was another answer. Okay, so those domains can be tricky when you have one of these fancy problems like this. Okay, so I could even try another one, but I think that's enough for now. If I kept going again, I think maybe I would be getting too big, because if I tried going around again, so I'm at negative 9, negative 9, negative 10, negative 11, negative 12, negative 13, negative 14, negative 15. So if I did one with negative 15 pi over 4 equals 2x minus pi. Let's see what happens there. If I add pi, I wonder if this one's going to be too big. I think this one's going to be too big, because negative 15 plus 4 is negative 11 pi over 4. Divide that by 2, I get x is equal to negative 11 pi over 8. Yeah, that one's too big. All right, so there's just these 4 answers. Oops. Those 4 answers. And on my answer key that I published before, I neglected to put this one in because I hadn't thought about it quite enough. Okay, so that is a humongous giant problem, and that would be sort of probably an extra credit type problem. If it's on the final exam, that would be kind of an extra credit. But these are real IB problems. So this is something that we want to be able to do, if possible, on the IB exam at the end of next year. All right, back to the packet. What is next? Okay, next we have a trig function, and we have the depth y of meters of water in a harbor is given by this equation, where t is the number of hours after midnight. Calculate the depth of the water at 2100. In other words, 9 p.m. Okay, so the depth of the water at the harbor, T is the number of hours after midnight. So 9 p.m., 21 hours, that would be right here. We want to calculate, we want to figure out what is the depth right here. So it looks like it's around 6.5, but to be sure, we are going to plug it into our equation. So this is a calculator type problem, I believe. Let's see what happens if I do this. So I'm going to get y equals 10 plus 4 times sine. The hours are 21 divided by 2. And let's see, 21 divided by 2 is 10.5. Yeah, I cannot take sine of 10.5. I cannot do that without my calculator. So I'm going to go ahead and figure out what that gives me. This is definitely a calculator problem. So grabbing my calculator, I'm going to have 10 plus 4 sine of 21 divided by 2. And I get 6.48. So I was pretty close. It looked like it was about 6.5, and when I actually calculated, I get 6.48. Notice I'm in radians here. So unless you're told to be in degrees, the default is radians. So 2.48, and that would be meters. Okay, what's the next question? Based on the graph, write down the maximum depth of water in the harbor. So the maximum depth is 14 meters. Calculate the value of T when the water is first at its maximum. So I want to find T when the water is first at its maximum. So right here, when does it first reach that? Okay, it looks like it's about 3, but let's go ahead and use our calculator to, they want an exact answer, so we're actually going to have to figure that out. Okay, so calculate the value of T when it is at that maximum. So let's write it out and see what happens. 4 times sine of T over 2. I want to know, when does it reach 14 meters? So here's my function, when does it get to 14 meters? So if we were going to do an exact answer, we're going to do it by hand. So minus 10. And I get 4 sine of T over 2 is equal to 14 minus 10 is 4. Divide both sides by 4 to get rid of that 4. So I'm left with sine of T over 2 is equal to 1. Oh, yeah, so this one we can do exactly, because sine of what angle is equal to 1. So if I change this to theta, sine of theta is equal to 1. What would theta have to be? Well, sine is the y value, so that would be pi over 2, 90 degrees or pi over 2. So theta is equal to pi over 2. So therefore, T over 2 has to be equal to pi over 2. Multiply both sides of the equation by 2, and I get T is equal to pi over 2 times 2. The 2's cancel out. I get T is equal to pi. That's why they wanted me to get an exact answer. How convenient is that? Okay, the harbor gates are closed when the depth of the water is 9 meters or lower. An alarm rings when the gates are opened or closed. How many times does the alarm sound during the day? So every time it goes past 9 meters, there's going to be an alarm. Okay, because the harbor gates are closed when it hits 9 meters. And I guess that means it's opened when it falls below 9 meters. So, let's see, when it goes above 9 meters, they open it back up. So every time here, here, and here, they're going to be opening the gates. So how many times does the alarm sound during the day? Well, a day is 24 hours, so 1, 2, 3. So it should ring 3 times. 3 times. Okay, find the value of T when the alarm sounds first. Okay, so the harbor gates are closed when the depth of the water is 9 meters or lower. So it's going to ring right here to close the gates. So that's what we want to find. It looks like it's about, the time is about 6.5. But we're going to find it as exactly as we can. So we want to know, when does the function reach a depth of 9 meters? So 9 meters, 10 plus 4 sine t over 2. We're trying to find time. Okay, so for this one, a couple ways I could solve it. I could do it algebraically, or I could graph it. I'm going to go ahead and graph it. I'll do it both ways, but I'm going to graph it first. So y equals, let's go ahead and put in 10 plus 4 sine of t divided by 2. And then for the second equation, I'm going to put in my 9. I'm looking for where they cross each other. Okay, I'm going to have to adjust my window. It's done graphing. Well, actually, I can see it. It's right there. But let's go ahead and adjust the window just for fun. So I'm going from, on my x, from 0 up to 24. And on my y, I'm going from 0 up to 15. That way it'll look like the picture. And then if I graph it, now it should look just like my picture on the paper. Okay, and I'm looking for that first intersection. So I want intersect. And let's move it over because I need left bound. Oh, just getting close to where I want to be. First curve, second curve. There it is. And I get 6.79. So t is equal to 6.79. Okay, we could also solve this algebraically. I could have done this algebraically, so let's go ahead and do that. So I could minus my 10, so I get negative 1 is equal to 4 times the sine of t over 2. And then divide by 4, so negative 1/4 is equal to sine of t over 2. I can then change this to theta. So, running out of room again. Let me get my scratch paper up. So let's say negative 1/4 is equal to sine of theta. So theta is going to be equal to sine negative 1 of negative 1/4. So let's go ahead and put that into the calculator. So negative inverse sine of negative 1 divided by 4. So that gives me theta is equal to negative 0.253 approximately. And I know that t over 2 is equal to theta. So I can substitute that back in. It's equal to negative 0.253. To get t by itself, I'm going to multiply both sides by 2. So times that by 2. So in my calculator, 2 times that answer. And I get, well, that's interesting. That's not helpful. What did I do wrong? Negative 0.505. Okay, what did I do wrong? 9, I minus 10. Divided by 4. That is very interesting. Seems to me I did something wrong, but I don't know what. So the graph was definitely my friend. And why didn't this work? Negative 1/4 minus 10, negative 1. All right, so I'm sitting here wasting time. So I'm going to go talk to myself off camera, see what went wrong.